Okay, welcome back. In our next section, we need to talk about a pretty straightforward but very important concept. We're going to talk a little bit about variables and constants and the rules of the road for identifying those variables and constants. A variable, fundamental concept, a variable is a piece of data in your program that takes on different values based on conditions in your program. We saw in our prior example, we saw radius. Radius is a variable whose value can change depending on different conditions in the program. One of the conditions being user input. It's a pretty common, not the only way, but a pretty common way for a piece of data to assume different values. Radius was also a variable, and it took on a different, it could take on a different value based on what? Based on the value of radius. Radius times pi r squared. So, fundamental and important concept. And when we have this information or this data in our programs, we need to give it a name or an identifier. And here on the slide, we'll see there are just some simple rules of the road we need to be aware of when we give a variable a name or an identifier. So what are the rules? Here they are. They're straightforward. An identifier is a sequence of characters that consists of letters, digits, underscores, and dollar signs. Letters, A, B, C, D, E, F, G. Be careful. One little twist there. Capital A and small a are different. So case matters, upper and lower case. It matters in Java and actually in many programming languages. So just be aware of that. Case matters. Digits, straightforward, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The underscore character and dollar signs. So these are the things you're allowed to have in an identifier. I recommend you stay away from dollar signs for now, and in some situations it's got sort of a little bit of a specialized meaning. So I might stick with letters and digits just for while you're getting your feet wet, while you're learning. So based on these things, next rule, the identifier must start with a letter, an underscore, or a dollar sign, or in other words, it cannot start with a digit. So I recommend you start your variable names with a letter. It's the most straightforward, and it's a very natural thing to do. An identifier cannot be a reserved word. It can't be a reserved word in the Java language. The Java programming languages has a number of reserved words. And in your text, and I recommend you do this, go to Appendix A, Java keywords, for a list of the reserved words. For example, class. Class is a reserved word. As we've seen in our prior examples, you cannot have a variable whose name is class. This word or identifier, if you will, is reserved by the language. So you cannot use it for a name of a construct, a variable in your program. Some other rules of the road: an identifier cannot have the value true, false, or null. So you can't have a variable named true, false, or null. They're used by the language. And finally, an identifier can be of any length. Now, that said, you really don't want identifiers that are, a couple hundred words, a couple hundred characters, or even 100 characters. You want it to be crisp and concise. So just be aware of that: crisp, concise, and meaningful. So let's look at some of these identifiers in action. We have the concept of variables in our program. Variables need identifiers. And in the examples we've looked at, radius, that's a variable. It's a variable whose value is 1. We could have another place in the program we could change the value if we wanted to. That's because it's a variable. It's designed to have its value changed. Area is another variable. Its value is pi r squared, radius times pi. And here's the example. We change the value later in the program to 2. Subsequently, the area is going to change. That's perfectly okay. They're variables. That's what they're supposed to do. When we have a variable in the program, in one of our programs, it must be declared. We must tell the Java environment, we must tell the Java compiler, here is a variable in my program. There's a couple pieces of information we need to give, and let's look at these examples here. So here is a variable whose identifier is x. We also need to describe or tell Java what is the type. What kind of a variable is this? In this case, all three of these examples are simple types, the first one being an integer. So here we have a variable whose identifier or name is x. Its type is integer. By telling it the type, that identifies the kind of values that this variable is allowed to take on in your program. Here's another one, a double, a variable of type double whose name is radius. So this says I have a variable named radius. The kinds of values it can take are a double. Very quickly, and we have a slide on this later, what's the difference between an integer and a double? An integer is, in Java, that's a 32-bit number, and without a decimal point, just 1, 2, 3, 4, 5. Those are integers. A double is a variable that can have a decimal point, 3.14159, the value of pi. That's a double. 2.5, 2.76, 1.0. Those are variables of type double. So in this case, we're declaring a variable whose name is radius, its type is double. And finally, we're declaring a variable whose identifier is just a and whose type is char. Char defines the types of values that the variable a can take on. A character variable can be, A, B, C, D, E, F, G, any of the alphabetic characters, but also it can take other variables as well, other values as well. As we'll see later in the course, you can actually have a character value, a character variable that actually has what looks to be a numeric value. You can have a character whose value is the character 1. Just be aware, and it's okay if this seems a little unusual to you right now. Be aware that the number 1 and the character 1 in a program are different. The character 1 is intended to be displayed for humans to read. The number 1, which is an integer, for example, is meant to be used in a calculation or represent a numerical value. So we declare a variable and we assign it a value. Recall we had a variable of type int whose identifier, whose name was x. So here we can give x the number 1, 2, 3, 4. Any of those are allowable. We could not give x the value of 1.5 or something. If we had a variable that required a number with a decimal point, we'd give it to a variable of type double called, and in our example, that's this variable called radius. So here we give radius 1.0, You know, we could give it 1.5, 1.8, any of those would be allowable values for this variable called radius. And here finally, if you recall, we had a character value, a character variable. Its name, the identifier, is A. In this case, its value is the character A. How do we indicate that a piece of data is a character? With these single quotes. So if we tried to do this, for example, the compiler would give us an error. An integer cannot take on a character value. So moving along, we can sort of combine the declaration. We can combine the declaration and the assignment of a value into one step. So here, what are we doing? We're saying I have a piece of data in my program. Its type is int or integer. Its name is x, or its identifier is x, and its initial value is 1. Here I've done the same thing. Here I have a variable of type double. So here's a piece of data. It's type double. Its identifier is d. Its initial value is 1.4. So here I've sort of combined. I've given it the type, so I've given it the type, double, the identifier, d, and the value all in one step. Now, a quick note on variables with decimal points in them. There's two simple types in the Java programming language. Here's another one. I could also have something like this. And let's get to case matters. So I could also have something like this, 3.25679 or something. Just made that up. Here I've also got a number with a decimal point in it. What's the difference? It's a reasonable question. What's the difference between this double, whose name is D, and this float, whose name is F? The difference is the representation in the Java programming language for a double. This is a 64-bit representation. The float, this is a 32-bit representation. The double is more precise. You can have more significant digits. It's really more appropriate for, for scientific or high precision computing. Now the trade-off is this takes twice as much memory as this. So you ask yourself the question, do I really need the double? And for simple programs, the answer is probably no. Most of the time. And for example, if you were just computing radius, maybe if it was for a scientific application and we wanted the radius to be real precise, yeah, we'd probably use a double. But if we just wanted to get an idea, and I don't mean to imply that there's not sufficient accuracy with type float, but if we needed less accuracy, less precision, we'd probably go ahead and use a float. So just a quick word on the simple data types. One final thing, and we'll leave this. We'll conclude this video and move on to the next. In addition to variables, you can also have constants in your program. A constant is a piece of data, piece of information. You give it an initial value, and it cannot be changed in your program. A great example is pi. Pi is, we could give pi a constant. So here we're declaring a piece of data whose name is pi. Its type is double. Its value is 3.14159, and here by adding this additional piece of information, final, this indicates that this is a constant. We cannot change this in our program. If we tried to give this another value later in our program, the compiler would give us an error. Here's the the similar thing here. We have a piece of data of type integer. Its name is size. Its value is 3. Final indicates it's a constant. It can't be changed. An important word on coding style. Notice that constants, the identifiers, are all capital letters. This is a very widely used convention. If you don't follow this convention, people will look at your code and they'll think there's something wrong with it. They'll think something odd, and it's just a convention. The compiler will let you get away with it, but it's so widely used for people that look at code a lot. They're used to seeing this. They're used to seeing that constants. They're used to seeing that constants are all capital letters. And just a quick final word on naming conventions. Choose meaningful and descriptive names for variables. We haven't really talked about method names, but for variables, use lowercase, and we'll talk more about this. But notice here is a very common construct. This is called camel case, where compute area, that's 2 words, lowercase to begin, and as you add other words, you give it a uppercase. So this is another convention that's very widely used. So let's leave it right there for now. In our next video, we'll talk about data types, but we'll leave it right there, and we'll see you in the next video. All right, that's it for now.